Nuclear propulsion includes a wide variety of propulsion methods that fulfill the promise of the atomic age by using some form of nuclear reaction as their primary power source. The idea of using nuclear material for propulsion dates back to the beginning of the 20th century. In 1903 it was hypothesized that radioactive material, radium, might be a suitable fuel for engines to propel cars, boats, and planes. H.G. Wells picked up this idea in his 1914 fiction work The World Set Free. Surface ships, submarines, and torpedoes. Nuclear-powered vessels are mainly military submarines, and aircraft carriers. Russia is the only country that currently has nuclear-powered civilian surface ships. Most are icebreakers, but one is a container ship. They use nuclear reactors as their power plants. For more detailed articles see Civilian maritime use, nuclear marine propulsion for civil use. List of civilian nuclear ships. Military maritime use, nuclear navy. List of United States naval reactors. Soviet naval reactors. Nuclear submarine. Torpedo. Russia's Channel 1 television news broadcast a picture and details of a nuclear-powered torpedo called Status 6 on about the 12th of November 2015. The torpedo was stated as having a range of up to 10,000 kilometers, a cruising speed of 100 knots, and operational depth of up to 1,000 meters below the surface. The torpedo carried a 100 megaton nuclear warhead. Aircraft and missiles. Research into nuclear-powered aircraft was pursued during the Cold War by the United States and the Soviet Union, as they would presumably allow a country to keep nuclear bombers in the air for extremely long periods of time, a useful tactic for nuclear deterrence. Neither country created any operational nuclear aircraft. One design problem, never adequately solved, was the need for heavy shielding to protect the crew from radiation sickness. Since the advent of ICBMs in the 1960s, the tactical advantage of such aircraft was greatly diminished and respective projects were cancelled. Because the technology was inherently dangerous, it was not considered in non-military contexts. Nuclear-powered missiles were also researched and discounted during the same period. Convair X-6, Myasishchev M50, Project Pluto, which developed an unmanned cruise missile that used a nuclear-powered air ramjet for propulsion. Aircraft nuclear propulsion. General Electric's project to build a nuclear-powered bomber. Tupolev Tu-95 Lal. Spacecraft. Many types of nuclear propulsion have been proposed, and some of them tested for spacecraft applications. Nuclear pulse propulsion. Project Orion. First engineering design study of nuclear pulse propulsion. Project Daedalus. 1970s British Interplanetary Society study of a fusion rocket. Project Longshot, U.S. Naval Academy NASA Nuclear Pulse Propulsion Design. AIM-STAR, a proposed antimatter-catalyzed nuclear pulse propulsion craft that uses clouds of antiprotons to initiate fission and fusion within fuel pellets. ICAN-2, a proposed manned interplanetary spacecraft that used the antimatter-catalyzed nuclear pulse propulsion engine as its main form of propulsion. External pulsed plasma propulsion, a propulsion concept by NASA that derives its thrust from plasma waves generated from a series of small, supercritical fission, fusion pulses behind an object in space. Nuclear thermal rocket. Bimodal nuclear thermal rockets conduct nuclear fission reactions similar to those safely employed at nuclear power plants, including submarines. The energy is used to heat the liquid hydrogen propellant. Advocates of nuclear-powered spacecraft point out that at the time of launch, there is almost no radiation released from the nuclear reactors. The nuclear-powered rockets are not used to lift off the Earth. Nuclear thermal rockets can provide great performance advantages compared to chemical propulsion systems. Nuclear power sources could also be used to provide the spacecraft with electrical power for operations and scientific instrumentation. NERVA, NASA's Nuclear Energy for Rocket Vehicle Applications, a U.S. nuclear thermal rocket program. Project Rover, an American project to develop a nuclear thermal rocket. The program ran at the Los Alamos Scientific Laboratory from 1955 through 1972. Project Timberwind 1987 to 1991. Ramjet Bussard Ramjet, a conceptual interstellar fusion ramjet named after Robert W. Bussard. Direct nuclear fission fragment rocket. Fission sail. Fusion rocket. Gas core reactor rocket. Nuclear saltwater rocket. Radioisotope rocket. Nuclear photonic rocket. Nuclear electric rocket. Project Prometheus, NASA development of nuclear propulsion for long-duration space flight, begun in 2003. Russian Federal Space Agency development. Anatoly Permanov, head of the Russian Federal Space Agency, announced that it is going to develop a nuclear-powered spacecraft for deep space travel. Preliminary design was done by 2013, and 9 more years are planned for development. The price is set at 17 billion rubles. The nuclear propulsion would have megawatt class, provided necessary funding, Roscosmos head stated. This system would consist of a space nuclear power and the matrix of ion engines. Hot inert gas temperature of 1,500 degrees Celsius from the reactor turns turbines. The turbine turns the generator and compressor, which circulates the working fluid in a closed circuit. The working fluid is cooled in the radiator. The generator produces electricity for the same ion engine. According to him, the propulsion will be able to support human mission to Mars, with cosmonauts staying on the red planet for 30 days. This journey to Mars with nuclear propulsion and a steady acceleration would take 6 weeks, instead of 8 months, by using chemical propulsion, assuming thrust of 300 times higher than that of chemical propulsion. Vehicles. Cars. The idea of making cars that used radioactive material, radium, for fuel dates back to at least 1903. Analysis of the concept in 1937 indicated that the driver of such a vehicle might need a 50-ton lead barrier to shield them from radiation. In 1941, Dr. R. M. Langer, a Caltech physicist, espoused the idea of a car powered by uranium-235 in the January edition of Popular Mechanics. He was followed by William Bushnell Stout, designer of the Stout Scarab and former Society of Engineers president. On 7 August 1945 in the New York Times, the problem of shielding the reactor continued to render the idea impractical. In December 1945, a John Wilson of London announced he had created an atomic car. This created considerable interest. The Minister of Fuel and Power along with a large press contingent turned out to view it. The car did not show and Wilson claimed that it had been sabotaged. A later court case found that he was a fraud and there was no nuclear-powered car. Despite the shielding problem, through the late 1940s and early 1950s debate continued around the possibility of nuclear-powered cars. The development of nuclear-powered submarines and ships, and experiments to develop a nuclear-powered aircraft at that time kept the idea alive. Russian papers in the mid-1950s reported the development of a nuclear-powered car by Professor V.P. Romadin. But again shielding proved to be a problem. It was claimed that its laboratories had overcome the shielding problem with a new alloy that absorbed the rays. In 1958, at the height of the 1950s American automobile culture, there were at least 4 theoretical nuclear-powered concept cars proposed. The American Ford Nucleon and Studebaker-Packard Astral, as well as the French Simca Fulgur designed by Robert Opron and the Arbel Symmetric. Apart from these concept models, none were built and no automotive nuclear power plants ever made. Chrysler engineer C.R. Lewis had discounted the idea in 1957 because of estimates that an 80,000 pounds engine would be required by a 3,000 pounds car. His view was that an efficient means of storing energy was required for nuclear power to be practical. Despite this, Chrysler's stylists in 1958 drew up some possible designs. In 1959 it was reported that Goodyear Tire and Rubber Company had developed a new rubber compound that was light and absorbed radiation, obviating the need for heavy shielding. A reporter at the time considered it might make nuclear-powered cars and aircraft a possibility. Ford made another potentially nuclear-powered model in 1962 for the Seattle World's Fair, the Ford Seattle ITE-21. This also never went beyond the initial concept. In 2009, for the 100th anniversary of General Motors' acquisition of Cadillac, Laurent Culisses created concept art depicting a car powered by thorium. The Chrysler Tv8 was an experimental concept tank designed by Chrysler in the 1950s. The tank was intended to be a nuclear-powered medium tank capable of land and amphibious warfare. The design was never mass-produced. The Mars rover Curiosity is powered by a radioisotope thermoelectric generator, like the successful Viking 1 and Viking 2 Mars landers in 1976.